Now let's take a look at a little bit about how regression works. I have actually taken the data from our previous example and plotted it on my calculator. We will see how to do this in a few minutes. Once I plot the data and once I get the equation, I will also get something called the correlation coefficient. On our calculators, or in statistics, that's commonly thought of as R. So R will stand for the correlation coefficient. We're not in a statistics class, and so all of the details of the correlation coefficient, including how to compute it by hand, will not be important to us. What will be important to us is the fact that the correlation coefficient measures how linear the data really is. If we were to obtain a correlation of 1, that would tell us the data falls into a perfect linear relationship with a positive slope. The closer R is to 1, the more linear the data. And again, positive values of R will always indicate that the data generally increases as we go left to right. An R of -1 tells us the data falls into a perfect linear relationship with a negative slope. The closer to -1, again, the more linear the data. Negative values of R indicate the data decreases left to right. An R close to 0 would tell us that the data does not indicate any linear relationship. If we were to look at our data that I did graph on the calculator, you would notice that this data looks pretty linear. I mean, the points are not a perfect line, but they do appear to kind of line up with a positive slope. And so I would expect I probably have an R here that is somewhere around 0.8, 0.9, maybe even a little bit higher. Now, if we take a look a little bit farther down here, what you should realize is in your textbook, they actually have some data sets and the corresponding correlation coefficients. In our text, those correspond to page 47, and I would encourage you to actually go to that particular place in the textbook and take a look at the data and observe those corresponding correlation coefficients.